this video, I'm going to give an example of backward stepwise selection. Remember, we use backward stepwise selection to help us identify extraneous variables that are in the model but not really doing that much. So the first thing I'm going to do is read in the data set, turn off scientific notation, get myself set up. Now let's just check how big the data set is. There are 730 observations in this data set and 16 variables that we've measured. Now, I'm going to create a model for average hours per driver, so how long is the day, based on 3 variables. One of them is weather conditions, so obviously the time it takes to deliver the packages would depend on weather, I would think. The percent oversized, and again, I would think that it depends on how many oversized packages the drivers are working with that day. And third, holiday, whether or not this is a holiday. Now, I'm not really sure what my intuition says about holiday, but let's see what we're looking at. Let's look at the summary. So according to R, weather conditions, percent oversized, and holiday are all significant contributors to this model. And the R squared that we start with is 45%. So that means that the 3 variables together are explaining 45% of the variation. But if I really want to understand what each one is contributing, I need to consider removing each one. So backward stepwise selection, the first step would be to run the model with all 3 variables and look at the R squared. The second step will be to consider removing one. So I'll call this round 1 just to identify what I'm doing. And I'm going to create 3 models. The first one, I'm going to remove weather conditions. I'm going to use dtrain percent oversized and dtrain holiday only. And of course, I want to look at the summary. For the second model, I'm going to remove percent oversized. So I'll have dtrain weather conditions and dtrain holiday. And look at the summary. For the third model, I'll remove holiday. So I'll have dtrain average hours per driver, dtrain weather conditions, and dtrain percent oversized. In each one, I've removed a single variable from consideration. And what I'm looking for is changes in the R squared. So remember, we started with an R squared of 0.45. When I run the model without weather conditions, the R squared goes from 0.45 down to 0.20. That means when I took weather conditions out, I explained 25% less of this problem, of the variation in average hours per driver. I'm doing a 25% worse job solving my problem. When I remove percent oversized, let's see what the effect is. I go from a total R squared of I ran the wrong code. Let's run this one. Now I got the same output, which I recognize because the R squareds are the same, but I didn't notice at first that there is some kind of error. So it says invalid type for variable dtrain average hours per driver. But the reason it's an invalid type is because it's missing, because I spelled it wrong. So I'm going to come over here and make a correction. I was typing and talking. When I rerun this now, I should get better results. So yes, the model ran completely. And I see that when I remove percent oversized, my model explanatory power goes all the way down from 0.45 to 0.15. So when I take out weather conditions, I'm losing 25% in my R squared. But when I take out percent oversized, I'm losing 30% in my R squared. Let's look at the third situation. I run this model without holiday. When I run it without holiday, I can see that my R squared goes down from 0.45 to 0.4385, which means I've only lost about 1% of my explanatory power. This is a tough call. It's borderline. It's not so tiny a contribution that I definitely want to remove it, but I want to consider it because that 1% of r squared that holiday adds really isn't that much. So let's say that in round 1, we've decided we're going to remove holiday. So now in round 2, we'll start with the model that removed holiday, where our r squared is 0.4385. And we'll consider 2 models. One where we remove, weather conditions and just keep percent oversized, and one where we remove percent oversized and just keep weather conditions. And we'll compare now to the r squared generated in round 1, which is 0.4385. So when I run that first model, my r squared drops from 0.4385 to 0.19, which means that I've really lost a lot of explanatory power. When I run the model without percent oversized, I can see my r squared also drops way down. So these variables are each contributing a really substantial amount of explanatory power to the model. So I want to keep both of these in. I don't want to take anything else out. So I'm going to stop here. And I've removed holiday, but it's pretty debatable. If that r squared contribution were less than 1%, say 0.5%, I'd be very confident that I want to remove it. I would also be more confident that I wanted to keep it if its contribution were higher. So it's really on the borderline, and it's a very subjective call, but it could go either way. The point of using backward stepwise selection is to say that you shouldn't always trust the results from R, because the results from R show all 3 variables to be significant, but their contributions are very different. Weather conditions and percent oversized each contribute quite a bit to the explanatory power, whereas holiday only contributes about 1% to the r squared. I think we could probably find better variables that do more, and we could live without holiday.